According to the International Maritime Organization, in the last decade, more than 100 bulk carriers have been lost at sea. Severe, sudden structural failure was a common contributory factor. Some of these ships disappeared without a trace. They sank so rapidly that the crew had no time even for a distress call. Some ships foundered or broke in half and sank. Some limped into sheltered waters after developing severe cracks. Severe and sudden failure of part of the forward structure is often a significant factor in the casualties. Failure of hatch coamings in the number 1 hatch could cause flooding of the number 1 hold, even without structural failure. Flooding of the number 1 hold would then cause failure of bulkhead between the number 1 and number 2 holes. Two main causes of structural damage are improper cargo handling and corrosion. High-density cargo, like iron ore, is often loaded as a heap. This asymmetrical cargo distribution produces stresses at various points. In case the cargo is loaded at one end of the hold, the lateral cargo pressure will act on the transverse bulkhead and cross-deck structures. In case of block loading, the lateral pressure on the transverse bulkhead will be largely cancelled, but vertical forces will be transferred to the bulkhead. Stowing of cargo asymmetrically about the center line induces torsional loads, causing a twisting of the hull girder and warping of the hull structure. Uneven deballasting of port and starboard tanks is another causative factor. In all these cases, the vessel may have loaded a correct quantity of cargo as per the loading manual, but the vessel is stressed at the end. Trimming of the cargo during and at the end of loading is very essential. Loading with a very high loading rate causes severe stresses on the ship's structure. Loading rates must match the deballasting capacity of the vessel. This is essential as many ports have high capacity loading systems. The rated loading capacity is the average capacity. In practice, short bursts of higher capacity are observed. Similarly, the ships quite often are not capable of deballasting at their highest rated capacity. A mismatch thus occurs. Ship shore safety checklist, as recommended in the BLU code, must be prepared and followed by the ship and terminal personnel. Communication arrangements between the ship and terminal should be capable of responding to requests for information on the loading process and of prompt compliance in the event that the master or terminal representative orders loading to be suspended. Consideration should be given to the disposition of cargo on the conveyor systems and the response time in the event of an emergency stop. The weight of the ship is balanced by the upward thrust of the water, the buoyancy. The differences in the opposite acting vertical forces causes the hull to shear and bend. In an unloaded state, the shear force is mild and shows a small peak at the stern due to the weight of the engine. When fully loaded, the shear force appears differently. If only the center holes are loaded or the weight is incorrectly concentrated in the middle, bending of the hull girder will produce sagging. If the weight is wrongly concentrated at opposite ends, the ship will get hogged. In addition to the static forces, wave action of the sea produces dynamic force on the hull. During heavy weather, the vessel sustains a heavy bottom slamming along with bow flare impact. In an improperly loaded vessel, capacity to withstand the dynamic loads at sea is reduced. Buckling of the side shell plating will result in flooding of the hold. Depending on the density of the cargo, loading is planned either as homogeneous loading, alternate hold loading, or block loading. Loading of the cargo is to be carried out under direct supervision of an officer in charge, as per the loading manual and loading instrument. Stress and displacement calculations must be commensurate with the number of cargo pause and loading sequence. At all times, hull stress limits should be kept below permissible limits. A study carried out by Classification Society members showed that a 5% overload placed in a hold could increase the still water bending moment by up to 15% and the shear force by up to 5%, while a 10% overload could increase the still water bending moment by up to 40% and the shear force by up to 20%. Similarly, if 10% of designated cargo from a hold is inadvertently loaded in adjacent holes, shear force and bending moment would increase by 17 and 33% respectively. Using two loaders of 10,000 tons per hour capacity, this could happen within 5.5 minutes. During unloading, the officer in charge must monitor stevedoring. Cargo handling equipment can damage the ship's structure through impact of grabs and other mechanical equipment. Structural damage and coating breakdown contributes to local weaknesses and may ultimately threaten the ship's watertight integrity. Corrosion initiates and enhances structural damage. Water ballast tanks were often left uncoated and corrosion starts during the first voyage itself. Proper coating of the ballast tanks and cargo holds will prevent corrosion. In order to prevent losses among bulk carriers, the International Maritime Organization has enacted regulations to enhance safety. This involves reinforcing and strengthening the bulkheads and wells. Contingency plans are to be made for specific cargo hold flooding. Hold flooding alarms and voyage data recorders are additional safeguards proposed. Safe working practices and a strict implementation of the Enhanced Survey Program will increase the longevity of these vessels. Bulk carriers are the workhorses of the shipping industry, but they need to be handled with care. Recap: prepare a loading plan and avoid overloading. Prepare a ship shore safety checklist. Supervise stevedore operations. Implement IACS guidelines.